Hi mathematicians, welcome to chapter 2, section 3. We're going to be talking about conditional statements. This is going to be brand new, so we're going to be doing a lot of learning today. So please make sure that you're taking care of yourself. You're pausing the video when you need to, writing down notes when you need to. After the video is over, ask somebody to quiz you. Study the vocab, keeping in mind that we need to study differently to do as well as we're used to doing. What we've always done is a really good start, and now we need to adjust. So we are going to analyze statements in if-then form, and then we are going to write the converse, inverse, and contrapositive of those statements. Okay, so what is an if-then statement? An if-then statement is a conditional statement. If this happens, then that happens. It is written symbolically like this. If P, then Q. We typically use the P for the hypothesis, the Q for the conclusion. The hypothesis is what immediately follows if. I know, super scientific vocab word, isn't it? Super scientific definition. P is the symbol we use. The conclusion comes following the then. It's what happens. It's the effect. And that variable is a Q. Again, pause the video as you need to get this written down. You're going to need to study it. All right, so we're going to identify the hypothesis and the conclusion in each of these statements. First one, if a polygon has 6 sides, then it's a hexagon. If, following if is my hypothesis. A polygon has 6 sides. Notice I did not include if. That is not part of the hypothesis. A polygon has 6 sides is my hypothesis. It is a hexagon is my conclusion. Notice I didn't include the word then. Hypothesis is a polygon has 6 sides. A conclusion is then it is a hexagon. If-then statements. The next one. Alyssa will advance to the next level of play if she completes the maze in her computer game. So this one isn't as clean cut as if-then. So we have to look through it. We got to kind of play with it a little bit. I see the word if, so this is what my hypothesis is going to be. Alyssa completes the maze in her computer game. That is the hypothesis. The conclusion will be Alyssa will advance to the next level of play. That is the conclusion. So it's not always super clear cut, and that's where your critical thinking skills come into play. What is the cause? What is the effect? If what happens, then what happens as a result? All right, so we are going to write these statements in if-then form. All right, if-then form. So we have to identify the hypothesis and conclusion first. Measured distance is positive, okay? So the hypothesis is going to be distance is measured. That's going to be my hypothesis, measured, all right? My conclusion is going to be the distance is positive. So my statement as an if-then statement, if distance is measured, then the distance is positive. All right? If-then form. If it's it's measured, then the distance is positive. Let's look at the next one. A 5-sided polygon is a pentagon. So my if, my start, my cause is I have a 5-sided polygon. Okay? Well, if I have a 5-sided polygon, it's going to be a pentagon. If it's 5-sided, then it's a pentagon. So if a polygon is 5-sided, then it is a pentagon. Okay. If a polygon is 5-sided, then it's a pentagon. If-then statements. Now, switching into truth values. So truth values are when we have a statement, is it true or is it false? Because we can make statements all day long. Like, today is October 8th and it is snowing. That's a statement. That statement is false because it's not snowing. All right? So you can make any statement you want. What we need to determine is if that statement is true or if it's false. That's what we're talking about here. So we have to determine the truth value of each statement. If it's true, we explain our reasoning. If it's false, we give a counter example. So how I should have said it was, today is October 8th and it's snowing. That is false because it is sunny and 68 degrees. There's no snow when it's sunny and 68 degrees. So when a rectangle has an obtuse angle, it is a parallelogram. If we have a rectangle that has an obtuse angle, it is a parallelogram. Well, what do you think? Can a rectangle have an obtuse angle? No. And this is a tricky one to have in the beginning because if your first statement is false, like it is here, we say that the whole statement is true by default. And this is not probably the best one to have at the beginning, but this is good to bring it up, okay? Rectangles don't have obtuse angles. So because this initial statement is false, you can't prove the truth value, so we say true by default. Odd. Hold that thought. We're going to explain that a little bit more later. Let's look at letter B. If last month was February, then this month is March. So if last month was February, not saying it is, but if it was, would this month be March? Yeah. So we would say that this is true. We'd say this is true. All right. This. I need you to pause the video and I need you to get this information in your notes. You will need to study it. This is all brand new. And so because these are brand new, we need you to practice that. These are called related conditionals, okay? So we're given an initial statement. For example, if measure A is 35, then angle A is an acute angle. That's a statement. It's got a truth value of true, all right? Now, from that initial statement, we can write 3 more statements, and those are called the converse, the inverse, and the contrapositive. The converse flips these 2 around. So instead of saying if the measurement of A is 35 degrees, then angle A is acute, it flips it and says if angle A is acute, then the measure is 35 degrees. It flips it. Again, we're not worried about if it's a true statement or not. That's not what we're talking about here. We are just talking about how do we write it. We'll decide truth values later. Right now, how do you write it? A converse, you flip the if and the then, or the hypothesis and the conclusion. An inverse negates both the hypothesis and the conclusion. So if the measure of A is not 35 degrees, then angle A is not an acute angle. Again, we're not worried about truth value. We just are worrying about how do you write the statement. And so contrapositive combines those two together. It flips it and negates both of them. Flips it and negates both of them. So if A is not an acute angle, then the measurement of A is not 35. Take some time, write these down. I want you to have somebody to quiz you on these. You need to practice. Practice, practice, practice. Pause. Okay, so let's take a chance to actually put this into motion. How does this work? Okay, how does this work? So write the converse. That means we flip the two. The inverse, we negate both of them. And the contrapositive, we flip and negate. We got to write these statements, make this as an if-then statement. Bats are mammals that can fly. So here we go. If a mammal is a bat, then it can fly. So that's my conditional statement. If a mammal is a bat, then it can fly. You should be writing this down. Hint, 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 hint. Okay? Converse. This one we flip. So, if a mammal can fly, then it is a bat. Converse, you flip them. And again, keep in mind that I want you to be pausing this to get this all written down. The videos are meant to be interactive. You're taking notes, you're working on it. If you've got questions, you're messaging me, right? Really need to have you being involved with that. Inverse, you negate them. Okay, so if a mammal is not a bat, then it cannot fly. Okay. If a mammal is not a bat, then it cannot fly. You're negating them. And with the contrapositive, you're negating and flipping, right? So if a mammal cannot fly, then it isn't a bat. Practice, 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 and practice some more. All right, here we go. Try this one out, pause it, and then come back. Did you pause it? Did you pause it and try it? Pause it. All right, here we go. Let's see how we did. The inverse takes the negates each of them. So not P, then not Q. So the inverse says, if you are not in rows 10 to 20, then you may not board. The converse flips the two. If Q, then P. If you may board, then you're in rows 10 to 20. And the contrapositive negates and flips. If you may not board, then you're not in rows 10 through 20. There you go. All right, so this is what I'm coming back to. If the hypothesis of a conditional statement is not meant, so it takes us back to that rectangle having an obtuse angle. If the hypothesis is not meant, the truth of a conditional cannot be determined. Crazy. So we say it is true by default. So as you're going through this, if the hypothesis is not true, by default, we say that the entire statement is true by default. All right, when you're finding truth values, when you're finding the truth value of it. I know this video got super long. There was a lot I wanted to talk to. Thanks for hanging in there with me. If you've got questions, let me know. Otherwise, take care.